Hey guys, welcome to another video for pre-calculus, and we're continuing our videos on 10.5 binomial theorem. I'm working out number 3 now, like I promised in the previous video. The previous video went about 15 minutes or so I wanted to cut that off at that point. And I'm working out number 3 now, where we have a negative in our B position right here. Okay, so let's go ahead and get started on this problem. So as I mentioned, we have this b right here, and it's a negative b. Now, you treat this a little bit different than, or you work it out just slightly different than you did the previous problem. There's a common mistake that's made here that I wanted to point out. Now, as I spoke before, the main formula, the general formula for a binomial is a plus b raised to the nth power. Well, you'll notice here that there's a negative b. And it's just a slight, one of the common mistakes that's made is that that the b is isolated by itself, where what you should be thinking is that you have a plus a minus b raised to the n power. So then my a term is whatever it is, and then my b term would be the negative b itself, the negative number. And so that's why I'm glad to see that problem here, because you have a negative b here. Let me write it in. So what I like to do is I'll just do a plus minus, so I know that I'm dealing with a negative b. So I take that negative sign with me. I carry it with me all the way through in the problems. So let's go ahead and work this one out. I'm going to start off with my Pascal's triangle. Again, that triangle of ones. And then the sum of those two bottom ones is 2, 1, 1. That's my second row. Recall that this is my 0 row because it corresponds with a plus b raised to the 0 power, right? And then this one corresponds with a plus b to the first power. And so this one is to the second right here. And then my next one, which will be 3, 3, 1, this one corresponds to the binomial a plus 3 raised to the third power, which is exactly what I have in this case. So this will be what my coefficients are in this type of problem here. And recall that there is a long way also with binomial theorem using my n choose r, which we'll address in a minute. And also the other way of writing it would be n choose r this way with the coefficient, to find the coefficient. So let's just work it out the way that we did before, where it's a little bit quicker. Not it'll take us just a few minutes to work out. So recall that I'm going to have my a term raised to the third power times my b term raised to the 0 power, and then of course I'll have some coefficient here that that will be determined by this row, which I already know, 1, 3, 3, 1, right? So what's my a term? My a term is 4a. So it's the 4 and the a that are raised to the third power. And then my b term is negative b. It's raised to the 0. Plus, my next term would be, or it's actually my terms are all the same, right? That's my a term times my b term, which is negative b. Okay? So this time my 4a, my a term is raised to the second, and my b is to the first. Plus my next. So 4a times negative b. Now this time my 4 is raised to the first and my negative b to the second power. And recall that all of my exponents are going to sum whatever my nth term was for my problem, which was raised to the third power. So all of these exponents should be equal to 3 when I add them together. And so then my next term and my last term will be 4a raised to the 0 power times negative b cubed. Okay, well, now all that's left is for me to find my coefficients, which Pascal's triangle helps me do that real easily. So my first term is 1, my second is 3, and then 3 again, and then 1. And now it's just a matter of simplifying. And let me just kind of simplify it. Let me work through it real quick so we can see how that works. So 1 times 4 to the third a cubed, and then negative b raised to the 0 is just times 1. So 4 cubed is, what is that, 48? 48a cubed, right? And then plus my next term, which is 3 times 4 squared a squared, and then negative b to the first power is just negative b. So I'm going to focus on this real quick just to get that part done. So 4 squared is 16 times 3 is 48 also, right? 48. 48 times a squared times negative b. Okay? All right. You know, I'm kind of curious here. I think I may have thought that one too fast. Let's see. 4 squared is 16, right? And then times 4, it's not 48 actually. Let's see, 24, 4, it's 64, not 48. Yeah. So that happens when you don't check your work there. Okay, and so for the next part here, I'm going to have 4 raised to the first, that's just 4, times 3, right? That's going to be 12. So plus 12 times a, and then here negative b squared is just going to be b, right? Or b squared, that is. Okay. So moving on, let's see here. I'm going to end up with here 1 times 1, because this is all going to be raised to the 0 power, so it's just 1. So that's 1, and that's going to be minus b cubed. Okay, well, that pretty much does it for that. That's that problem simplified. So now let's work it out the long way, okay? So let's work it out the long way. So again, I have 4a minus b cubed, I'm sorry, minus b, and all of this is cubed. So my a term, I know will be raised to the third power, and my b term is to the 0 power, and then it's going to be, now I'm going to be using my binomial theorem, which is n choose r, right? N choose r. So my n is 3, and my r in this case is always that second term right there, so it's going to be 0, plus my n choose 1 for my next term, so that's 4a, and it goes down 1, and then my negative b goes up 1. So again, notice how my b or my r is always there. This is the same number. Right, let me get rid of those, so just in case some confusion. Okay, and now for my second term, so that's n choose r, which in this case will be 2. So that's 4a to the first, and negative b to the second. And then my last term will be plus n choose r, which is 3. And so now I know I'm done. When those two numbers are the same, I know I'm done. So my a term raised to the 0 power, and my b term raised to the third power. Okay, so now let me show you how we end up getting our coefficients with this notation here. And I'll do it for just a couple of them. So recall that my binomial theorem is n choose r. So that n, it's the factorial of n divided by n minus r, the factorial of that, and then my r factorial. So my n for my first term is going to be 3 factorial over 3 minus 0 factorial times 0 factorial. So that's 3 factorial times, or divided by 3 factorial, and then 0 factorial. So I know that these will cancel out and will give me 1. So that will give me 1. But I already knew that it was going to be 1 because I used Pascal's triangle. Okay, let's work out one more. One more will be n choose r. In this case, it will be 3 choose 1. And that will be 3 factorial divided by 3 minus 1, which is a 2 factorial times a 1 factorial. And remember, the factorial notation just means that it's 3 times 2 times 1. You just multiply it by the previous number. and then 2 times 1, and then times 1 for 1 factorial. So you know that this will cancel out right here. That gives me 3 over 1, which is 3. And of course, with, put this in there, with Pascal's triangle, I was already able to figure that out at a much faster pace. So, all right, I'm gonna just do one more. Let me just do one more for good measure. I'll do this one in red. So this is going to be 3 choose 2. So that's 3 factorial divided by 3 minus 2, which is 1 factorial, times r factorial, which is 2. So I have 3 times 2 factorial at the top, and then 1 factorial is 1, divided by 2 factorial, so I know that this cancels out, giving me 3 over 1, which is 3. And again, because of Pascal's triangle, I already knew that. Okay, so that does it for these problems. For problem 3, or at least for this type of problem, where we are using Pascal's triangle to expand a binomial. So I hope this helped, and good luck in your study.